and welcome to Group 3 video presentation for the scheduling application operating system. Group 3 includes 3 members including Dave, David, and Samuel.
Hey there, let's understand the code first come first serve. So the algorithm first come first serve in this code take 5 arguments, includes a variable process, variable end, waiting time, variable turnaround time, and a context switching time. So next I'm creating an empty list called WT, which is waiting time, and assigning equals to 0 for now, and which is create an empty list to store the data. Similar with turnaround time.
Good afternoon. My name is Samuel Brangman, and I will be going through the round-robin algorithm in our operating systems group project. First, we started by creating a list called burst time. But since this list is empty, we will be iterating through the processes array, which we use to collect the data from the text file, which coincidentally has the burst times stored from the text file. And we iteratively go through that to add them to the burst time list. Then we create a loop that checks if the burst times are greater than the quantum times. If the burst time is greater, we take the quantum time, setting the new burst time to equal the difference between the burst time and the quantum time. So we know how much is left for the next iteration. If the burst time is less, we simply take the burst time.
Hi, this is David, and I am in Group 3, and I will be working on the shortest job first algorithm. So as you can see here, this is it. So the first thing that we're going to do is we're going to create a function, and in the function we're going to have the processes, the wait time, turnaround time, all that stuff. As it says here we're defining a shortest job first that takes 4 arguments, processes, and WT and TAT. And then first we assign the remaining time to equal to variable 0 and then multiply by the value n. Then we create a for loop, and in that for loop we're going to assign the remaining time equals to the processes, and we're now going to set initialize complete at 0, and we're also going to initialize t at 0. So first we're going to make a minimum, which is going to equal the float infinite to store the remaining burst time. Then we're going to also create the initialized short end check as well. So in this while loop, we're going to create one that will execute until all the processes have completed, of course. And we're going to create a for loop inside that while loop. And in the for loop, we're going to use it to check if j has arrived and the remaining burst time is greater than 0. Then we're going to assign the variable minimum to equal the variable of time, assign the short to equal j, and then to make sure that the check is equal to true, it is originally equal to false. If it's not checked, then we're going to continue iterating through the for loop. And then once that is done, the remaining time is going to be decremented by 1 to simulate the execution of the one-time quantum. It updates the new value of the remaining time of the process short, and if minimum is equal to 0, then it assigns a variable minimum to equal to infinite to store the remaining burst time. If short is equal to 0, then it's going to complete the value, its increment by 1, to simulate the execution of one-time quantum. If check is equal to false, it's going to indicate that a new process needs to be selected for execution of quantum. And then this is to assign the last one, fins equal to t plus 1, is to assign the finish time to t and then add 1 to that. The wait time is then going to be calculated by the difference between the finish time and the selected process and its arrival time. If the waiting time is less than 0, then it's just going to equal 0, and t, then after all of that, like once the for loop is done, then t is now incremented by 1. Then another for loop is created. This calculates the process plus the waiting time to get the turnaround time. And that is essentially how the shortest job first algorithm operates.
So now let's understand the next algorithm, which is shortest remaining time, which take 4 arguments for a variable process, variable end, waiting time, and a turnaround time. For next line, it is which is RT, which stands for remaining time. I'm assigning equals to 0 multiplied by a variable n for now. And I'm creating a for loop for I in a range. Next line is a remaining time I'm assigning a remaining time equals to process for now, just like we did in first come first serve. Then I'm assigning a complete equal to 0 for now, time equal to 0. Main float is assigning equals there because of to restore the remaining burst time right there. So stored, I'm assigning the stored equals to 0 for now, and check is equals to false right now. So I'm creating a while loop next to it, and so it will continue executing until all the processes have been completed, obviously. So after that, I'm assigning a for loop right there for j in a range, right, for now. So if a process j is less than t, and remaining time is less than mint, and rt, which is remaining time, is more than 0, then main will be r equals r, it will be equals to remaining time, short will be equal to j, and check will be turned to true, where assigning a variable check equals true. Yeah. So if it check if any process was selected to be executed during the current constant time. If there is no process having selected, the system will be incremented by 1, as you can see, and it will be continue the process. Then remaining time value is discriminated by 1 to simulate the execution of the one constant time, as you can see. After that, I'm assigning a main equals to remaining time, and if a main is equals to 0, then it assigns a variable main equals to float to store to store the remaining burst time, as you can see. So, and if the remaining time is equal to 0, then complete will be incremented by 1 to simulate the execution of one constant time. And check is set to false to make sure that new process need to select for the execution of the constant time. Then I'm assigning a if condition there for remaining time. If the remaining time is equal to 0, then the complete value will be incremented by 1 to continue it. And if the check is set to false, so the new process need to select for the execution in a constant time. So faint is equal to t plus 1 for there. It is assigning a finish time to t plus 0. Right. So according to the logic, the waiting time, as you can see, the waiting time will be equals to faint minus process 2, which is process 1 and process 2. As you can see, it calculates the difference between a first time, finishing time, and a selected process, and its arrival time process and burst time to get the waiting time. Right. And if a waiting time is less than 0, then waiting time will be equal to 0 then. It will be essentially equal to 0. And the t value is incremented by 1. After that, I'm creating a for loop for right there to continue the process. And it calculates the process plus waiting time to get the turnaround time in the output. Hey everyone, now since we understand how the algorithm works, let's understand how the interface is going to work. So let me show you. So when I click on run, and I click on debug it, so code will start running, and first it will ask me to select a text file which is required for the project. So I'm going to select this text file and I'm going to click open it. So it asks me to select the what I want to enter as a context switching time. So for now, I just enter any random number that will too big. Let me decrease it. That will be good. When I press enter, it will ask me to select what algorithm I want to run it. So for now, I'm gonna select the first come first serve. As soon as I hit enter, it will immediately give me the waiting time and a turnaround time right there. And for the graph, it will be shown here. As you can see, the graph is perfectly working there, right there, and you can hover on it to see the x and y, exact x and y location of your pointer exactly at the top corner. Let's do another one. For this time, I'm gonna run it again. That's really bad. So as I said, it will do the process and it will ask me to select a file. So for that, I'll select this file, the text file, and again ask me to enter a context switching time. So this time, let's enter a different number. So I'm gonna press enter. This time it also ask me to select the algorithm. So for this time, I'm gonna select round robin, which is also a hard one. For there's a condition in RRR. So if the user select a round robin, it will also has to be entered in time, right? So for content time, I'm gonna enter, let's say 21 second or so, and I'm gonna press enter. It will right there give me the waiting time and a turnaround time, and the graph will be shown right here for the process. That's how it works. Now close that. Now let's understand how this code can run. So first, when the algorithm completes here, I'm running a file right there, driving a file path. So it will open a box as shown you that allows the user to navigate to the directory and select the file. Once the file is selected, it will be saved into the code for that time. Then, as a context switching time, it will ask me to enter the context switching time, which is stored in code also. Then it's asked the user to enter which algorithm they want to run, and according to the user's response, the code will assign the algorithm that job. And as I said, if the algorithm as the user select RR, it will also has to ask for the constant time, as I showed you before. And everything will be here I'm creating a process which is an empty list to store all the data that we done and numbers in the file. So first it's just the first line and with open file. So it will just open the file. Then it will read the file with the then you open the file then read the file. Then creating a full right there to run run every single line. So during the running, it will see that is there any space there or how many splits there, all that stuff. And according to that, it will assign to it will determine that it is a context, which is like a waiting time, what's the process, all that stuff. It will determine it that way. Then I'm assigning n equals to len is the process. Don't forget the process is the same list that is created to store all the data from above. So I'm assigning n equals to len to return the number of items in the counter as a process. And next to I'm assigning a waiting time equals to variable 0 multiplied by n. Same thing with the turnaround time, and I'm creating a new variable called total waiting time and a total turnaround time to calculate the total turnaround time. Right. Then next to it is work with the when the user select the algorithm there. So if the user select first come first serve, it will run this command, it will run this process, which is also mentioned right there, which is also a 5 arguments of first come first serve. It will run those 5 arguments. Same thing with round robin, shortest job first, and shortest remaining time with all of that. Then I'm creating a for loop for the process next to it, which is there is also total waiting time is also assigned at the top there, which is also assigned to equals for that time. Now it will also now according to this code, the total waiting time will be incremented with the waiting time in the code that's selected at the time, and the turnaround time will increment with the turnaround time only. The total turnaround time will be incremented with the total turnaround time only. Yeah. So then it will be according to this call, it will assign an average waiting time equals to total waiting time divided by the n variable. As you can see, it will do the same thing with the turnaround time. The average turnaround time equals to average turnaround time divided by the n. So the total turnaround time divided by the n, right? And as you can see here, it will calculate that and will print the statement. So as you know that when we run the command, when we enter the numbers and we select the file and stuff, we select the algorithm, it will give us the waiting time, total average waiting time, average turnaround time by the end and just in seconds. So that's how it gives us. So it will say average waiting time, and then it will print the whatever the number is coming from the total waiting time divided by n. That will be average waiting time for the process. Now the next big thing is how do we implement it in a graph? So here I'm assigning it. Here I'm assigning x and y axis. So first it creates an empty list called x axis to store the data, and same thing with the y axis to store the data. Then I'm assigning a current time equals to 0 for now. So because it's just started, that's right. Then I'm creating a for loop for the variable n. Then basically it's at the x-axis, the current time is updated by the adding the waiting time of the process of the current process, and it updates the time adds in the x-axis, and the current process ID will be added into y-axis. Easy. And it will be printed like that. The graph will be printed like that. Same as here. The current time is updated again by the the execution of time and the current process, and it updates time. It updates time adds into the x-axis. And same thing as above, the process ID will be appeared in the y-axis, which is assigned to a time, I guess. Yes. Then it runs, then it keep running the same thing called due to the for loop. So here the current time is updated by the adding the context switching bit time, which is the time it takes to switch from the one process to another. As before, it will increment by the current time with the it will as before, the process ID will be printed on a y-axis, and at the end it will increment the current time with the context switching time, just like here, 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 right there. It will every time it will incorrect by the first, the context switch time incorrect by the waiting time, then the current time will be incremented by the process, and at the end current time will be incremented by the context switching time there. So after all of that process, it finally creates a graph from all the data that it stores. So I'm assigning it to variable. I'm assigning it to argument. I'm creating a build.step function that take two arguments, x and y, which are the arrays or the used to create the plot for the graph. Right? So I'm assigning an x label to time and a y label to process to print the graph, and at the end adding a show command to show the graph right there. So let me see, the graph is not there, so let me show again that how everything works. So it will do all the process, and first as the core, it will ask me to select a file right there. So let me show you here. There's the graph. This is the process running right now. So I'm selecting the file, make sure I show the correct file, and click open. So when I click open, it's asking me to enter the context switching time, which is right there, which is this line, context switching time. So I'm gonna enter again any number, whatever, and I'm gonna press enter. Then this line, the line 108, it will ask me to select which scheduler and I want to choose. This time, let's select the shortest job first, just for the test. I'm gonna press enter. As soon as I press enter, it will do all the calculation. It's shown there, and it's do all the x and y axis, do all the process in a second. It will assign all the graph and everything, and it gives us average waiting time here and average turnaround time here. And as I showed before, the graph will be printed up like that. Here's the graph, and you can also see the exact cursor point where you look at it at the top of the graph. Yeah, so that's that.
So at the end, thank you for your time. We hope you enjoyed the presentation. Have a wonderful day.